Kia ora koutou, welcome to this next video of acids and bases, where we will look at how to write the formulas for ionic compounds. So writing ionic compound formulas or formulae. With the last video fresh in mind, we looked at the cations and anions, that when they transfer electrons, they then have a charge and are attracted to each other, and that attraction is called an ionic bond. When we're writing ionic formulas, the one thing that we need to keep in mind is that ionic compounds have no overall charge. So we're going to look at some simple examples. I'll get straight into it because that'll be the best way to explain what I'm going to be talking about. So the first one will be lithium fluoride. So if we look at the periodic table and find lithium and fluorine, we've got lithium in group 1, so that means it will form an ion with a charge of positive 1. Fluorine is in group 17, which means it will form an ion with a charge of negative 1. So what we're going to end up with is, these are the examples below that you can see that we're going to go through. So we've got lithium, which forms an ion with a charge of plus 1, Li+. Fluoride will be F-. When these ions bond together, keeping in mind that ionic compounds have no overall charge, we will need 1 lithium per fluoride to make this ionic compound work. So the way that we would write that is just Li. We write the positive ion first, just like we name it, LiF. And once we've drawn this, written this chemical formula, we don't need to then write any charges because there's no charge overall. So when we're working it out, sure, we can write the charges, but once they've bonded together, we don't write any charges. We just leave it as lithium fluoride. Guarantee there'll be a few people who will write some charges there, and that's fine, but it just takes a lot of practice. Okay, we'll do another one, magnesium oxide. So magnesium is in group 2 of the periodic table, so we'll have a charge of plus 2 when it forms an ion. Oxygen is in group 16, so that will have a charge of minus 2 when it forms an ion. So I'll draw it out. So we've got magnesium Mg plus 2, or 2 plus, should put the number first, and oxide will be 2 minus. So the 2 plus cancels out the 2 minus, so we just have magnesium MgO, just like that. That's how we would write the ionic formula for magnesium oxide. And then one last one, potassium chloride. Potassium is in group 1, chloride's in group 17, so we've got potassium, which is a charge of plus 1, chloride has a charge of minus 1. So to write that ionic formula, we would write KCl, because we just need one of each, and then we have an overall charge of 0. So these are, I'll put them all in boxes, these are how we would write the chemical formula for ionic compounds. Where I've written the ions here, that's just the working to get to this final result. So notice the final result does not have any charges written on it. So some trickier examples. Look at magnesium chloride. So magnesium, as we saw, was in group 2. So we've got magnesium, which is Mg plus, 2 plus, and chloride, which is in group 17, that was Cl minus. So if we have one magnesium ion and one chloride ion, we're still going to end up with a charge of negative 1. And that breaks the golden rule that ionic compounds need to have no overall charge. So what do we need to do to make the charges balanced? Well, one way to kind of visualize this is that for these trickier ones, if I just draw a circle around that magnesium ion, and then I'll draw one line for each charge, and then around the chloride ion, I'll draw one line to represent one charge. Once all of these arms are connected up, we could say that that is balanced. It's just a way to visualize it. You could think of other ways. We could look at it mathematically, but this works for a lot of people. So we can just do another chloride there, and then we will link up that other arm. So now both of the magnesium charges are linked up. So we actually needed 2 chloride ions for every magnesium. If we don't have this ratio of 2 to 1, then there's going to be a charge overall, and that's not going to work. So we've got 1 magnesium, 2 chlorides. How do we write this as the chemical formula? Well, we just write magnesium as normal, and because it's the cation that comes first. Then to show that there are two chlorides, we would put Cl, and then you put a little 2 down the bottom right hand side there. So that little 2 tells us that there are two chlorine atoms as part of this ionic compound. Okay, so we'll now look at the next one, sodium oxide. So sodium has a charge of +1. Oxide has a charge of 2-. So if we do the same thing as before, I'll use blue for the negative charge. So each oxide ion has 2 charges there, and the sodium just has 1 charge. So we need to balance out the arms on the oxide ions. So the 1 sodium ion, that's not going to cut it, because that's going to still end up with a charge of -1 when we put those together. So we need to have another sodium ion there. So put another sodium ion, we can link it up with that arm, and so we've now got 2 sodiums for every oxide. So how do we write that? Well, we do the same thing. We write the cation first, Na, and then we need to show that there are 2 sodium atoms. So we do the same thing as we did up there, but this time the sodium's coming first, so we just put a 2 there, and then we need to show that there's 1 oxide ion, so we do the oxygen there like that. So it's just Na little 2 O, and then there's no, like I said, there's no charges when we put it all together like this. That is our final result for the chemical formula. Okay, we've got quite a few that we're going to do, just as good practice, and they're going to get gradually harder. So calcium nitrate. So remember, when you see that word 8, well, that part of the word 8, that indicates that it is a polyatomic ion. So here we're going to have Ca2+, because calcium is in group 2. So that's got 2 charges coming off it. And then nitrate was NO3, and you just have to memorize this, NO3 minus. Well, you don't have to memorize it, because you get given a table of ions. So you just need to memorize the name of it. You don't need to memorize the charge. So NO3, that's got 1 charge on it, so we can link that up with the calcium 2+ charge there. But if we just had 1 nitrate per calcium, then overall the ionic compound would have a charge of +1. So we need to have another NO3 ion for every calcium ion to balance out the charges. So we've now got 2 nitrates and 1 calcium. So how are we going to write that? So these chemical formula, something important to realize about them is that they are just showing what's happening in our compounds. So these numbers are really important to represent what's actually going on. So what's actually going on here is that we have 2 nitrates and 1 calcium. So we'll put calcium there. That Ca tells us that there is just 1 calcium. And then we need to show somehow that there are 2 NO3s. And so this is slightly trickier than the last one, because if I was to just put a 2 there, that would say that we've got 32 oxygens, 1 nitrogen and 1 calcium. And in reality, we don't have 32 oxygens, we've only got 6 oxygens. So we need a trick to be able to show that there's 2 nitrates, 2 of the whole thing there. So what can we do? Well, this is where brackets come in. So we would use a bracket to show that there's 2 NO3, so there's 2 nitrogens and 2 times 3 oxygens. That's a little bit messy, but that's how we'd write the chemical formula for calcium nitrate. Now, lithium sulfate, I'll push through as quickly as I can, try and get this done. So then we've got lithium, Li+, and then SO4 minus, 2 minus, sorry. So we're going to need 2 lithiums per sulfate. You could draw that out yourself. So what we're going to do is Li2 SO4. Notice in this case, because we only have 1 of these polyatomic ions, so there's no brackets that are needed. That's a tricky one that will trip people up. And finally, the ultimate hard one, we've got aluminium sulfate. So Al is in group 13. It's got 3 electrons in its outer shell. So it loses 3 electrons to form a full outer shell. So we've got 3 charges coming off that. And then we've got a sulfate ion, SO4 2-, which has 2 charges. So we can link up those 2 charges there, which are 2 charges coming off that. SO4. So we need another sulfate, 2 minus. Just trying to wrap this up, and there's like a crucial 10-minute mark. I'm trying to get this done within. So we've got a second sulfate. If we link that up there, we've now got a dangling arm. So that's not going to work. We can't just have a 1-to-2 ratio. So I'm going to have to make another aluminium, which is going to give me 1, 2, 3 more charges. So we've still got 2 dangling arms, and we need to make sure there's no dangling arms whatsoever. So we're going to do sulfate 2 minus again, which will link up to those 2 dangling arms, and we've now balanced it out with 3 sulfates and 2 aluminiums. So the way that we show that using chemical formula is Al2 to show that there's 2 aluminiums, and then we're going to need a bracket, SO4, and we put 3 there to show there's 3 sulfates, 2 aluminiums. Give this a go. It's really satisfying once you get it, but it can take a bit of work to get it right. Thanks very much for watching. Like and subscribe for more science videos.